Positive terminal is reaching directly at this terminal. 1, 2, 3, 4. In this case, 3 capacitors. To increase the voltage rating, these are connected in series. To increase the capacitance, these are connected in parallel. Assalamu alaikum wa rahmatullahi wa barakatuh. I am your host Muhammad Ashraf and I welcome you on my YouTube channel. This is our second video on AC Tech MC3000 series VFD M3450 400-480 volt input 3 phase 50 or 60 Hz output, 0 to 400 volt or 460 output and 0 to 120 Hz output. AC Technology Corporation, USA. In last session we disassembled it. We checked what are the main parts and today we will perform cold testing. If you don't have good experience in electronics, never try to repair, because if you will apply power, this board will be directly exposed to line voltage 380 volt, 400 volt. Even it is removed from the line, these capacitors may hold charge. Always take care for the safety. We will perform cold testing for this board because this is the main board that is directly exposed to input voltage and it handles the load. Before touching to this board, verify voltage on these capacitors, this capacitor bank. Never touch any component until we are confident that there are no voltage. If there are voltage, we will discharge it. If it is connected to power supply, disconnect from the line voltage, discharge it, verify it, and then work. DC voltage, no voltage, no voltage. We will see the circuit combination, how this circuit is assembled, and what are the basic checkpoints for troubleshooting. Set multimeter to continuity. These are 3 input terminals. And here is bridge rectifier. You can see in this board there is no fuse, there is no EMI protection circuit. It will receive directly line voltage, high current. This will reach to AC1 terminal here. L2. This will reach to AC2 terminal here on bridge rectifier. L3. It is reaching to AC3 terminal, and there must be no short circuit between input terminals. If you find short circuit between line terminals, that means the bridge rectifier will be damaged because it is the first component that is connected on input terminals. Diode mode, black lead at negative DC terminal, red lead at positive terminal. Multimeter will show some reading and then it will open. Reverse the leads. Black lead is at positive terminal, red lead at negative terminal. If you will connect in correct polarity, after charging the capacitors, multimeter will show OM. This is good reading. If you find continuity here, beep, tone, that will indicate that there is short circuit on DC rail. Here are 6 capacitors. 1, 2, 3, 4, 5, 6. Line 1, line 2, line 3. These are reaching to bridge rectifier. First line here, second line here, third line here. On each line there are 2 diodes. because it is line to line rectifier. So output voltage VLL minus 2VD, diode voltage. We can say we have 400 volt. 400 by under root 2, 565 volt minus 2 volt that are for diode drop voltage, 563 volts. This voltage will appear at positive and negative terminal of the bridge rectifier. Positive terminal is reaching directly at this terminal. 1, 2, 3, 4. In this case 3 capacitors. Negative side here, these 3 capacitors are connected in parallel. Positive is reaching here directly. Here are 390 microfarad 400 volt capacitor. 390 microfarad 400 volt. $390 multiply with 3, 1170 microfarad. These 3 negative terminals are connected together, and these positive terminals are connected together. But here, this positive terminal is not connected to this positive terminal. This negative terminal is connected to positive terminal of this capacitor. This is negative terminal and this is positive terminal of this capacitor, and its negative side is connected together. Its negative is not connected to this line. So 3 in parallel with series with other set. We have 2 sets, the same. 390 microfarad 400 volt, 1170 microfarad for this bank, and 1170 microfarad for this bank. Now we have 2 capacitor banks in series. The total capacitance 1170 divided by 2, 585 microfarad, 400 plus 400, 800 volts. Why these are connected in this way? Because 400 or 450 volt capacitors are available. To increase the voltage rating, these are connected in series. To increase the capacitance, these are connected in parallel. So total capacitance 585 microfarad, 800 volt. Our rectified line voltage in case of 400 volt, that will 563 volt. If 460 volt input, depending on the different regions, 480 to 678 minus 2, 676 volt. Because this VFD has 2 functions, line high or line low. Line low on this voltage rating, line high with that voltage rating. Let's assume 400 volt or 380 volts. 563 divided by 2, 281 volt. When we will connect three phase, line 1, line 2, line 3, this set of three capacitors will receive 281 volt and this will receive 281 volt. Both in series will receive 563 volt. Here is another thing. Two NTCs are connected in series. Mention here NTCs. And these will be bypassed by a relay. These are connected in negative line. This negative line is reaching here at this point. Then this NTC 5.3 ohm. This is 3 ohm NTC. Negative line is reaching at this point. Then to this NTC and then finally here. Two NTCs in series. Normally we are receiving 5.3 ohm resistor between negative line. It will provide controlled current to charge these capacitors. When this relay will turn on, when this power supply will start, that time this outer line will provide voltage to this relay winding. Here are 2 points of this winding. That time this relay will bypass that NTCs. So we will receive direct voltage from here. And this point is connected here at negative side of first set. Its part number is 125-003. This positive line will reach to P pin, positive pin of this IPM. This pin, this positive line, this terminal will reach to positive terminal P pin of this IPM. Intelligent power module. And negative side of this set will reach to N pin. Positive at P pin, negative at N pin. We will check negative with chassis, open circuit, positive with chassis, open circuit. If we find continuity here, that module will damage. That must be replaced. If we find continuity between this positive terminal and this negative terminal, IPM will be replaced, that is short circuited. Here we have 5 pins, P, N, and these are 3 output pins. One line, this is second output, this is third output. Black lead at one line, set multimeter to diode, check with positive terminal, check with negative terminal, one diode. Now replace lead. The same terminal, output terminal, here open circuit, here one diode, positive terminal. In this condition, one diode with negative terminal of first set, or we can check here with N pin, one diode, P pin, one diode. Here reverse bias, here forward bias. Second pin, open circuit, one diode. Reverse the leads. Open circuit, one diode. Same here. One diode, open circuit. Open circuit, one diode. Its high power switching stage IGBT section channels are looking good. Its ballistic diodes are good. If any condition that provides continuity between this point and this terminal or this terminal, direct continuity. Here we are finding diode drop voltage. If you find continuity, that IPM is unhealthy. That IPM has internal short circuit. So that must be replaced. There is no interchannel short circuit. Here are bleeder resistors. 62 kilo ohm, 62 kilo ohm. This for this set, this for this set. When power is removed, this 62 kilo ohm resistor will discharge both capacitor banks. This one and this one. It will take around 2 to 3 minutes. We have these resistors here. So positive and negative terminal is reaching to IPM. Positive, negative. And we have UVW or T1, T2, T3, whatsoever. This IPM will receive signals, control signals, drive signals that are SPWM signals to generate three-phase SPWM, sinusoidal pulse width modulated signal. In upcoming session, we will discuss the second board, control board, and finally we will assemble it. We will check its function and we will discuss what is the input, what is the output, and how it works. Here is MOV, metal oxide varistor. It is 12G911KM. 12 size, G general purpose, 911, 910 volt, 910 volt that are clamping voltage at 1 milliampere. This is the top limit. The working voltage 676 volt in case of 480 volt input. If the line voltage has more swelling or there are more voltage, at 910 volts this MOV will clamp voltage and it will protect the next circuit, IPM, and it will protect the bridge rectifier. These resistors are named bleeder resistors, and also these are called balancing resistors. These will create balance between both capacitor banks. Then, to protect both capacitor banks, there are ceramic disc capacitors that are connected in parallel to each bank. Here is CM, ceramic disc capacitor marking, 1M. Normally it is 1 microfarad, 20%, 1000 volt, and E is temperature coefficient. In some capacitor markings, 1M is coded for 100 picofarad, 1000 volt, and plus minus 0.5 picofarad tolerance. So we need to remove it, then we can verify what is the voltage rating here. How much current is flowing in the circuit, that will be measured by this Nana LX10 current transformer, that is this one. It will check the amount of the current and it will provide that information on this connector that will be provided to microcontroller here. Here is MOSFET, Zener diodes, power supply circuit. We will check it practically. When we perform this cold testing and all these checks are good, that time this board is safe to apply power. We can power it up. Then any error, any fault code will be displayed here. Based on that fault code, we can take approach to specific area to rectify that fault. In upcoming session, we will assemble it and we will check function of this interfacing board, that is isolation board, optocoupler board. It provides isolated SPWM signals to IPM drive side, and then IGBT will provide switched voltage on this line to the output. We will discuss this control card and we will see the function, how this VFD is working, what is the output type. We will use oscilloscope to monitor these signals. If you think this video is informative, you can like it. If you have not subscribed my channel until now, you can subscribe it. We will continue in upcoming session. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.